it. Let me know if you have any background noise issues or something. Okay, cool. All right, so from today we are going to learn about basically Spring applications. Okay, whatever we have learned so far were the concepts or practices that you will see being used in a Spring application. Okay, so if you have any doubts about this, you can go through the recording or you can personally reach out to me. But most of the things that we have learned so far will be used here. Okay, so what is our agenda today? We are going to learn a few concepts. Okay, this is actually messed up a little bit. I explained to you about the idea of container yesterday, exactly what a container is. I told you that it provides two things. A way to register itself, okay, plus a way to retrieve. Okay, so we'll see what specifically Spring container is. Okay, then we'll understand what a Spring Bean is. Okay, these are mostly going to be conceptual. Then we'll understand Spring Bean life cycle. Okay, and it's very important for you to understand at least this and this, because number one, interview, number two, you'll be a better programmer in Spring if you know these things. Then we basically have something called how do I so it's actually called scope, but I'll explain to you what a bean scope is. Okay, and we'll explain something called singleton versus prototype. Okay, and so I'm just explaining the order in which I'll explain all of these concepts to you, and then we'll actually have a walkthrough of Spring application. Okay. All right. So let's talk about Spring container. If you go through the, like, I'll open up the previous project just to explain the concept of container once again. Okay. If you look here, voice. By the way, as I was telling you guys, this is your GitHub link. You can go here and check the code. Okay, you can actually see all the commits I've done here. But basically, the latest one is actually here, like this commit.
Hello.
Yeah.
Sir, your voice is too low, sir.
Voice is it the same for anyone else?
Sir, you.
Yes, sir. Yes, sir.
Voice is what, breaking up?
No, it's too low.
Now? Is it fine now, dude? Hello.
Fine, sir, but some noise, background noise.
Acha, acha. Background noise. I have to get myself a better headphone, I guess. Wait. Is it clear now? Is it better now?
Yes, sir.
Yes, sir.
Okay, cool. Cool. All right. Okay. Okay. So let's talk about Spring Bean. Okay. So what is a Spring Bean? Okay. Before we understand what a Spring Bean is, does any of you know what a Java Bean is? A yes or no would do.
No, sir.
No, right? You don't know what okay, there's a chat here. Your voice is low. Okay, that's okay. Huh. Okay. So basically, let me create one right here. let's say I have a class like this. Okay. Uh, and let's just say this is this is basically a student class. It captures information about a student. This is called Pojo or a Java bean. Okay, in the Java enterprise world, this is a Java bean. Okay, now if this Java bean had a life cycle attached to it, as in if you could see when this was getting created or see when this was getting destroyed, as in if you had control over the life cycle of this particular Java bean, it would then be called a Spring Bean. Okay, so Spring Bean, you will get different like sort of confusing definitions online, but just know that in reality Spring Bean is a Java bean or a Pojo with some additional life cycle attached to it. Okay, I'll explain to you in a moment what a life cycle is. Right,
Sir, what do you mean by Pojo?
plain old Java object. Plain old Java object. There is no functionality. This is just a this particular class is called a lot of things. Okay, it's called a DTO, which is known as data transfer object, which is it. This object right here is just a bag. This class is just a bag. You put your things in the bag and you carry it somewhere. This student class, this class, if you create an object out of it, it has no particular function. It just captures information and gives it to whoever needs it. Okay, so this is also known as plain old Java object. So POJO, Pojo. Okay, and basically Pojos with life cycles attached to them is, or especially life cycle managed by Spring, is basically a Spring Bean. So the thing is, what exactly is a Spring? Why do we even need to care about a Spring? So see, there are many ways in which you can develop a web application. Okay, you have Express.js. If you are coming from the JavaScript world, you have Node.js, Express.js. If you're in the Python world, you have Flask, and then you have Django. So what happens is uh, every language has a framework with it with which you can build a web server. Okay, we'll come in the later sessions as to what a web server is, who's a server, who's a client. Okay, all of these things. But for now, just know that Spring application is nothing but a Java application, but it has some functionalities which an ordinary Java application does not have. For now, this much information should be enough. Okay, all right. So let me show you a picture of uh, the different types of life cycle that a Spring Bean has. Okay, uh, and the two major life cycles that we usually deal with. Not Geeks for Geeks. Let me just show you an image. Okay, let's take a look at this image. Okay, let's start with the first thing. It says container started. Okay, so by looking at this, you know that there is going to be a container involved in this thing. Okay, the main functionality of a Spring container is to manage the beans or manage whichever Spring classes or Java classes with Spring functionalities are getting added. So in Spring application, you never create a Spring Bean on your own. Okay, you register a Spring Bean and then you ask the container, hey, give me the Spring Bean. Okay, you would never, I mean, you can create simple objects as we'll see in the examples. You can create a simple give me a second, dude. Okay, sorry about the interruptions. So basically, you have a Spring container, which is essentially going to manage the beans for you. Okay, as in, uh, as we'll see in the application, majority of the Spring beans, they are not created by some other bean. They register themselves, and whenever someone needs a particular bean, they basically ask the container. So what happens is, first the Spring containers start up, because the Spring container also is a Java object. So this guy first starts up, and then it basically goes around finding out what the beans are. So I told you, right, this Spring container, I mean, any container should give you a way to register and a way to retrieve. So Spring container basically looks for all those places where registration has happened. And then let's say, for example, it identifies that there's a Java class which has registered itself as a Spring bean. Okay, what happens is it first instantiates the bin. Okay, then it basically injects the dependencies. What do we mean by that? As if this Java object has a dependency on some other Java object which is also a Spring bean, okay, then those things will be created, then they will be injected, then we can move on to the next method. Okay, this part is important for you to understand. As the container starts, it immediately starts scanning your entire package. Like for example, if your container is sitting here in this home package, okay, or let's say your container is sitting in this parent package, okay, then if your container starts here, it'll Spring container will start scanning all the packages, all the sub packages and their sub packages for any kind of bean registration. Okay, if it finds a particular bean, it will first create the bean with the, like, it will internally create a bean before it makes it available for you. Okay, that phase of this cycle is called the bean instantiated. Okay, it has just been created but it's not ready for use. Then it will basically scan the class and it will see whatever other classes that this guy needs. Okay, and then what it will do is it will go and check, are those classes already instantiated? If those classes are instantiated, they will then inject it. If those classes are not instantiated, then they will create them first and then inject them at this phase. So this is the phase where the dependencies are injected. Why are they called dependencies? I explained earlier. If your the data that you need to work with, or the object that you need to work with, you don't create the object in your class. Like if you just need to work with it, you leave the creation to whoever your caller is. Okay, uh, and then what will happen is those dependencies will be injected. Then there will be a custom init method, then there will be a custom utility method. This is where your Java methods will come to use. And then there is a custom destroy method. We are basically given access to this method and this method. Okay, so this entire thing is a Spring Bean lifecycle. Don't worry if you didn't understand, we'll go through one by one. Okay, so first of all, let me actually go ahead and show you how to create a Spring application. Okay, I'll head over to something called Spring initializer. Okay, you can see that it has start.spring.io. So you click on this. Okay, now here let me just tell you about what these are. Okay, so this project is going to be managed by Maven. Okay, don't worry about Maven and all that. Further in the classes I'll explain what Maven is, but for now just know that Maven is a dependency manager, or it's just something that will manage your project for now. Okay, the language we're choosing is Java because JVM can run other two languages as well. It can run Groovy and it can also run Kotlin. So we have to specify what language we want. It is Java here. Now it says what version of Spring Boot you want. Okay, so every Spring application you create, okay, you have a parent Spring parent project. Okay, okay, every project that you create, every Spring project, your custom Spring project will have to be coming from here. And parents have different functionalities, and with different functionalities come different versions. So for example, some of the facilities may be available here but not here because this is an older version. Okay, it's just like versioning, like how you update an app there, it's like that. Okay, right now if you are working on your let's say in on your own ideas, but you're not actually working for a company or something, you can use the latest version, which is always a snapshot. But you can see that there is a version here with snapshot in the bracket, and then there's a version here with no snapshot. What is the difference? This is a full build. Okay, this is not work in progress. These snapshots basically means that there is still more functionalities being added to this. Okay, still more functionalities are being added to it, so it's not a complete product, which means that there is a possibility that some feature might not work, although that's not the case here. But usually when you work for a company, they will always go for the latest reliable version, and the latest reliable version is the one without any of these things, snapshot or m2 m3, none of these things are there. Okay, so we'll go with the latest reliable version, which is 2.6.5. And we are missing out on the latest let's say features, because there are lots of features before this, but those features are not complete yet. Okay, cool. Now you have the project metadata. Okay, so let me explain what project metadata basically is. Project metadata in sense is data about your project. Okay, this basically says group, artifact, name, description, package name, and packaging. Okay, let's go one by one. What is a group? Let's say Geekster is it's building an application. Okay, it's building something like Amazon. Okay, and basically an online e-commerce website. Okay, now online e-commerce website comes under, like, it is composed of many things, right? You have a cart system there, then you have a payment system there, then you have a search system which searches the products and everything. Okay, all of these things, each of these small tiny components are called artifacts. Okay, and the group is where, like, if you have a mega project which is Amazon, and then inside Amazon you will have payment, order, cart, this, that, all those payment, order, carts will be artifacts, and Amazon would be the group. Is this clear for you? Somebody has question. Anish Kumar has a question, raised a hand. Yes.
So artifact server.
Artifact. Acha. Okay. Hmm. Okay, how do I explain this to you? Let me give you a visual representation. Okay. Let's say Geekster decided to open up a car manufacturing company. Okay. Now, what it'll do is it will have okay. Let's just say Geekster designs a car. Okay, they have a Geekster manufacturing company. Okay, now this manufacturing company has several units, right? Because one guy cannot do everything, so they have separated out a team. One team is just manufacturing the tires, one team is just manufacturing engine, one team seat, one team chassis, and a lot of other things. This thing Sorry. This is an artifact. Okay. Similarly, this is an artifact. Whereas this whole thing is a group. Does it make sense now? Anish?
Yes, sir.
You're perfectly clear with the concept of group and artifact, right? Okay, cool. Similarly, if we are building something for Geekster, I showed you yesterday that the convention is always that if your site is something like geekster.in, okay, you would always write it in reverse fashion, in.geekster. Okay, now what are we building here? We are building a hello world application, or we're just building a Spring, let's say, tutorial. Okay, which means that under this tutorial we'll have several artifacts. We'll sometimes learn about Spring Core, sometimes we'll learn about Spring Data, Spring JPA, Spring Hibernate, database, and all those things. Okay, each of those will be artifact, but they will all come under this group called Spring Tutorial. Okay. Okay, so what we'll learn here is a simple hello world application. Hello world app. Okay, name can be anything. Demo project for Spring Boot is just a description. You can leave it out for now. And you can see the packaging name is in.geekster.springtutorial.hello world application, which means this guy is an artifact. Okay, it has its own set of codes. Then when we create something else, that will have some other set of codes. Okay, but they will all come under in.geekster.springtutorial. Okay, packaging would be jar, and the version, Java version, would be 8. Okay, cool. Is there any question on this part before I move to dependencies? No. Okay. In the dependencies, so what exactly are the dependencies? Yeah, Abhishek, does you have any question? Abhishek, I request you to type it in chat. Please type your question in
Yes, sir.
chat.
Jar and var.
Acha, okay. What is the difference between jar and var? Good question. So, you know that you can run a simple Java application by typing Java hyphen jar and then your app name, right? App dot, let's say, app.java. Okay, you can run your Java application like this, right? But what if you, so what will happen with this is this Java application will basically once execute and then it'll shut down. Okay, but what if you need to keep a Java app running? Because if it's a web server that you're building, right, you want the web server to be available all the time. Okay, I'm hitting this URL, right, google.com. If google.com was just a simple Java application, it would run, execute, and it will be done. Okay, I won't get to see this page. Okay, somebody out there is keeping that Java program alive. Okay, that is what the web server does. Like if I could give you a pictorial overview. Okay, let's say this is your app. Okay, you need some wrapper around it. Okay, which is going to be the okay, this guy, this outer shell is going to keep running your app so that it stays there. Okay, it doesn't close or shut down or anything. So this part, this entire part is called a war. What this, I mean, sorry, my bad. This part, what it's called is it's a war file. This will give you basically a war file. Now you need a container, a web server to run this war file. So if you are generating a war, you would have to find out a web server, and then basically you would basically have to put this in here for your application to run, for your application to be alive. Okay. A jar, what it basically does in this sense is, in Spring jar, a jar would basically be this. Okay. So it would contain the web server as well as your application. Does it make sense?
Yes, sir.
Cool. All right. Okay. Let me just delete that. Cool. So if you have no more questions here, let me move on to the dependencies. Now, what exactly are dependencies? See, in the software industry, you are probably going to need some function which is already written by someone. Okay. For example, you are, let's say you're going to read a file in your, from your computer to your Java application. Okay. Java gives you classes like files reader, input stream, and all those things. If you didn't have those things, then you would have to manually do them. You would have to manually go and read them from the uh, using your Java application. But somebody has already done those things for you, and they have published that somewhere. Okay. Maven is basically a dependency tool management. We'll learn about Maven later on. Okay. But just know that Maven has something called Maven Central Repository. Okay. If you have a library that many people can use, if you have something useful that many people can use, you would publish your library or your framework in this Maven Central repository search, and anyone that is using Maven can basically start using your library. Okay. So similarly, so that library is basically a dependency for your project. Okay. So here we are going to have to specify the dependencies for our Spring project. Now pay attention to the dependencies. We are going to build a simple Spring application, right? So the first thing we'll need is a Lombok. This has nothing to do with Spring itself. I'll tell you what Lombok does. Okay. Uh, then you have something called Spring. mm, you can attach something called Spring Web, and I think that should be it for now. Okay. So for a simple Hello World Spring application, you would need the Spring Web, and you would need Lombok. If you see here, this has a tag of web. Okay. This is what is going to build your web application. This Lombok is marked as developers tool, which means it helps in development. It has no specific function which the application is going to benefit from. You are going to benefit from this, hence the developers tool. Okay. We'll see how Lombok works. Okay. So after this is done, okay, I'll go ahead and generate the class, and it will give me a zip file. But up until now, does anyone have any question about this?
No, sir.
Okay, cool. So we'll go ahead and generate, click on generate. You can see it actually downloaded a hello world app.zip. Okay. So what I'll do is, the first thing is I'll go to my workspace, March. What is the module we're teaching? We're teaching Spring Core. Okay. So we'll go here, Spring Core. And I think this particular course is Spring Beans and Lifecycle. Okay. So what I'll do here is, I'll create this. Sure, let's do it like this. Beans. Okay. This is our. What? Let me just check once. This is part of your Spring Core. This is fine. Spring Core, and then you'll find your this thing here. Okay. This is fine. Okay. So I'll go inside the Spring Beans lifecycle. This part you can ignore because, if you're on a different machine, you probably won't understand much. But what I'm doing is wherever I downloaded my file at, I'm just copying it from there. Hello world was the zip folder. I'll bring it here. So now I have this. I'll unzip. I'll remove the zip. Okay, and I have my hello world application. Okay. Let's open this hello world application from my IntelliJ ID. So what I'll do is I'll close this project, and I was creating new project. This time I'm going to open. Okay. In open, I have Spring code. In this, I have Spring Beans and Lifecycle. So I'll open this hello world app. Okay. It'll take some time initially to basically load everything there is. But yeah. So what did we decide to learn today? We decided about the life cycle of a Spring Bean. We'll see what a Spring Bean is. We'll see different ways to hook into the Spring Bean life cycle and what exactly a Spring container is and all that stuff. Okay. Cool. Is it done? It's taking some time to resolve. You can see it says Maven. So while this does this thing, let's talk about what Maven basically is. Okay. Maven is, maybe it would be better if I could just Apache Maven. Maven is a piece of software. It's an open source software maintained by the company called Apache, and it is a build automation tool primarily used for Java projects. Okay, what exactly is it? So your Java application, like I said, it needs, let's say it wants to reuse some functionality, like somebody out there has written some functionality or some library. It wants to basically use that library. So there you can, so there are two ways you can basically use a library function. You can go to the library itself. You can download that library, and you can, if you're an IntelliJ, you can actually come here and you can see that there is something called external libraries. Okay, so you can either paste it here. Problem with this approach is when a different version of that library comes, or when the library updates, you would have to manually remove all the libraries from here and then re-download those libraries and add them here. Okay, that is a manual process and it's a very tedious process, which is why Maven came up. Maven said that I'm going to manage everything for you. I'm going to manage the tools for you. I'm going to manage all the dependencies for you. If the dependency updates, I will do it automatically for you. You don't have to do anything. So Maven is basically a build tool. Okay, so all of these commands that you'll be running, right, java -jar and all those things, Maven will do them automatically for you. So Maven will make sure that before it builds your application, your Java application, if it depends on some library which is out there, it will download those dependencies first and then it will build. Okay, so it's kind of like this. How do I explain this to you? If you were to do things manually, you would first have to do download the libs, or let's say dependencies. Okay, there can be multiple sites here. You can download from www.google.com or some, let's say, some random site. Then you would have to basically put them under appropriate folder. If this is if you were doing things manually. Okay, okay, and then you would have to run your Java application. Okay, Maven does things differently. Maven basically has one single command that will do all of these things for you. Okay, so that's why it's called an automation tool. Okay, anyone has any question? Okay, okay, cool. So just for now, just know that Maven is actually just a dependency management tool or a build tool. Okay, that should be enough for now. As we go deeper into this, we'll understand what Maven is and we'll understand the intricacies. So you can see here, Maven actually, any project with a Maven dependency generates something called pom.xml. Don't worry about these files as of now. Just know that it generates something called pom.xml. Let's understand what pom.xml is. In the pom.xml, it's this structure that you're looking at. Okay, for those of you who are freshers, this structure that you're looking at, this is called an XML structure. Okay, in XML structure, you have a parent tag here, and then you have its own variables here. Okay, and then this parent tag ends here. So every tag that it's kind of like HTML code. Okay, every tag that you open, you would have to close it, and whatever value you put inside of it will be the value taken by this. Okay, so let's go through this briefly, and we'll see what this Pom XML does. So this Pom XML for Hello World this is the place where you would define if you need to work with some dependencies. Okay, let's check the first thing. You can ignore this for now at this point. Just make sure that these things are there every time you work with a Pom application. Let's start with this. Remember how I told you that every Spring application that you create, okay, your custom Spring application will actually have to come from a parent project. That means Spring team has already created some project for you, which you can use, and it's like you are extending this thing. Like if you consider this as a parent class and this is your subclass, you're basically extending from the parent project. The same concept applies here. Inside this parent tag, you basically specify these three important things. Okay, first thing is group ID. Which group is the project that you're looking for part of? Okay, here, like I told you, if it was Geekster, I would have written Geekster dot something. For this, they have something called org.springframework.boot. Okay, so all the Spring Boot related components are actually inside this group here. Okay, then you have something called the artifact ID. This is the actual code base. This is artifact ID is the place is the it is the actual jar file that you need. Okay, so you have Spring Boot starter.parent. I mean parent. This is the parent which is like the class that you're extending. Okay, this is the specific version that you're extending. Okay, and if you see here, if you open up external libraries for, I think for Eclipse, you will have something similar to this. But if you see here, right, you have many of these things: Apache Tomcat, Apache Faster XML, all of these things here. Where are these things coming from? These actually, if you see, these are all jar files. Okay, like if I open this up, open in, I don't think they will open up anyways. Okay, how do I open this? Let me just show it to you. Okay, workspace, March, Spring Core, Beans lifecycle. Okay, this is my Hello World application, and there is okay, no, this actually won't be here. This will be in some M2 repository. Let me just check. Don't worry about what I'm doing right now, but basically, so as you specify these things, right? I specified that I am dependent on this parent project. So whatever the parent project had, you have everything available to you under this external libraries. Why is it called external library? Because you're not internally creating anything. You're basically specifying a site where it's fetching all these libraries for you. Okay, this is the parent part. Okay, then this is my group ID and my version. Okay, this was the parent's group ID and version. You can ignore the relative path for now. This is my own identity. I am part of in.geekster.spring tutorial. I am creating the artifact Hello World app, and the version here is 001-snapshot. Why is it snapshot? Because what I'm building right now, it's not complete. So I will go ahead with the snapshot. Okay, this is just a naming convention. This is how you you give a signal that my project is usable, but it's not production ready. Okay. Then you have something called basically the name of the app, and then description and all of these things. In the properties, you see you have something called java.version. Okay, in the property section, this particular property java.version, it basically specify what is the language and the version of it that you will be using. Language is java.version and then 1.8. If you had Kotlin, it would have written Kotlin.version, something like that. Okay, then comes your dependencies segment. Okay, you can see that this dependency actually ends here. And if you see here, remember we added a Spring Web there. That's the dependency we added here. And then we added something called Lombok. Okay. So these are the two dependencies we have added. This is something that was auto generated. So Spring basically has some inbuilt testing classes, which will always succeed if you do not tamper with it. Okay. If you write your own test classes, then you have to make sure those test classes pass. For now, we'll ignore this thing because we're not doing any testing or mechanism here. We'll just focus on these two. Okay. If I go back to my Spring initializer, I've mentioned Lombok here. This is the Lombok part here. And then I mentioned Spring Web. This is the Spring Web part here. Okay. In the Lombok, you can see that this Lombok, whatever version we're using, artifact we're using, it's part of a larger group called org.project Lombok. Okay. Lombok has many things. Lombok is a developer friendly tool. I'll show you how it is developer friendly. And then you have the artifact Lombok. Optional is true. Don't worry about these other things. Just know these two things. Okay. And similarly for dependency here, I've specified that get me this particular web artifact from this Spring Boot. If you look here, I'm actually depending on two artifacts. If you see here, this group ID and this group ID, they're the same. Okay. Which means that under this project, there are sub projects. One of them is Spring Boot Starter Parent, which is the parent of my project. And one is Spring Boot Starter Web, which is not a parent of my project, but it is like a dependency of my project. I am specifying that I need this particular sub project in my own project. Okay. Any questions here? Any confusion here so far? You can either drop a message in chat or you can tell me up front. I'll do a recap just to make sure that nobody has missed out anything. Okay. You come to Spring Initializer. Here you specify the project language. Project, under this you have two options: Maven project, Gradle project. We always choose Maven project. Maven is a build tool, is a dependency management tool, which basically does a lot of things for you. You don't have to do things manually. For now, just know this much, that it's a dependency management tool. It manages your dependency, it builds your project, and does all of those things. Okay. Then we basically specify what language it is. We are using Java, so Java. Then in the Spring Boot application, we have said that we are going to use the latest stable build. And how do we know what is stable? The ones without the M2 or M3 or snapshot. Okay, those are the stable builds. So in the industry, there's something called LTS, which is long-term support. It is like that. It is an LTS, long-term support. Okay. So that, and then in here I explain the concept of group. If you have if you are building something and that something requires smaller things, those smaller things will be known as artifact, and the bigger thing will be the group. Okay. Then this is your name of the application. This is a description. This is the packaging name that is automatically generated when you type here. Then we're specifying what I want, whether I want a jar file or a war file. I told you in this whiteboard here that if you take a war file, then you need a web server, an additional web server to keep running your application. If you take a jar file, the web server will be a part of your jar file. Okay. That's basically what it is. Here we specify the version. You can see that Java has actually come up with version 18, which is insanely, like, we're lagging by. I think next time if you guys work in the industry, you'll see working with Java 11, because Java 8 will be like, most companies would move away from 8 into 11. Okay. But for this tutorial, we have been advised to work with Java 8 because many of you don't have good computers. So yeah, so we'll use Java 8 here. Then comes the dependency part, where we are saying that in order for this project to work, what are the two things I need? First thing I need is the Spring Web, because it's a web application, and Lombok. We'll see what that is. These two dependencies have been mentioned. And as I generated this thing, it gave me a zip file. I unzipped it and I opened here. Then the first thing I looked at is my POM. POM here basically specifies the parent class. I mean, the parent project. Okay, which project I'm extending from, their group ID, their artifact ID, and their version. Then I have given my group ID, my artifact ID, my version, and the name of my application. The description, whichever I specified there in this, came here. Okay. And then the properties. In the properties, I've mentioned the Java version, which is language version 1.8. And then the dependencies, the two dependencies that I have included here are part of this. this is something that Spring automatically generated. We don't have to worry about this one for now, okay? And we also don't have to worry about this entire build part here for now, okay? As we go into more classes, I'll explain all of these things to you, okay? Cool, that's the Maven part of things, okay? Let's actually see what else we got here. We got an .idea, which is generated by this IDE. If you were working with Eclipse, it would have generated something else, so we don't have to worry about that, okay? Then you have something called .maven. Okay, .maven basically has a wrapper file which has a Maven wrapper and Maven wrapper properties. We'll discuss about this thing later, okay? Because this is not important. Your main focus would be on source folder because this is where your Java class will be placed, okay? In the source folder, you have two things, main and test, okay? We are not going to work with test here because unit tests are something which will be, I think, part of level up session and not part of this. So majority of our code will be in main. But basically, if you write unit test cases or integration test where you're testing your application with database or testing your application with some other Spring application, all those tests will be written here. If you see, if you open this thing, you already have a hello world app application tests, okay? It is written to you and it is annotated with Spring Boot test. Basically, this is where you would write your test cases. But again, we're not going to learn about tests here. So we'll focus on main. Okay, let's open main here. You have two things. You have a Java and a resources. Okay, we can ignore the resources for now. Let's just focus in Java. Okay, in this Java, you can see the packaging name that we saw here. This is the packaging name that they have followed. So it is basically saying that for every item in the Hello World app would be part of this package. Okay, and in here we are automatically generated one Java class which is called Hello World app application. Okay, right, this is what our first Spring application or Spring Boot, whatever you call it, is. Okay, so let's just try running this for now. So for this, what I'll do is I'll go back to my workspace, March, Spring Core, Spring Bean lifecycle. Okay, hello world. Now, the command to run, the command to compile a Spring application and run it is mvn clean install. Okay, what this command will do is it will basically clear all your dependencies and re-download all the dependencies. Okay, so clean and install, and then it will generate a jar file. This part will generate the jar file. Your job would be to then run that jar file. Okay, let's see how or what this functionality does. By mvn, you are actually going to allow the Maven to work. Now, okay, so whatever happened here, this command, you cannot see anything here, but if you go to this particular target folder, right? If you go to this target folder, you will see that it has all of these things. One thing is there, that is hello world app, this .jar. This is the file we actually need. This is where all our classes and everything is stored. Okay, so that's what Maven, that's what this command did. Maven clean install, it generated this thing. If I just run Maven clean and not install, you can see that the target folder itself is gone. Okay, so what it did, it just cleared everything. It cleared all your dependencies and everything. And then if you just say mvn install, it will go ahead and create that thing for you again. It will create the target folder here again. Okay, now for those of you that do not know or do not have Maven installed in them, for them there is something called Maven W. Okay, this is what your Maven wrapper basically does. So if you look at this, right, this folder, when you download it from Spring, it gives you everything out of the box. You don't have to install Maven additionally. you can just use the Maven wrapper in this given to you in this thing. So I was issuing this command mvn, right? For in order for you to use Maven command, you would just have to use mvn w. Okay, that's it. Um, that's for Maven wrapper. So if you want to use Maven wrapper, you can use it. If you want to install Maven, you have to probably watch some tutorial to install Maven on your computer. But the basic necessity is that you have your Java installed on this thing. Okay, cool. Let me see how we do it using Maven. So the command on Linux would be dot this mvnw. This is actually equal to running this mvn. Okay, so when you say mvn, it assumes that your system has this thing. If you don't have mvn installed on your system, you can just use this command dot slash mvnw, and that will work. Okay, and then you can pass the same command clean install, and then it will basically generate the Spring application for you, that jar for you. Okay, any questions so far?
Sir, please explain again how we run this file.
How we run Maven?
Yes, sir.
Okay. So first thing is you come to the parent folder, hello world app. This is the parent folder. You have all of these files in there. Okay, if you have Maven there, you would say if you have Maven installed on your system. How do you verify if you have Maven installed or not? You would type mvn version. You can see my system already has Maven installed here, basically 3.8.4. Okay, and it also tells me the Java version running on my machine. It gives the location at which the Maven is installed. If you do not have Maven installed on your computer, you can either install it by watching some tutorial or something. It's not that difficult a job, or you can use the Maven W wrapper. Okay, so for Maven W wrapper, this I typed right. Instead of doing this, you can just say mvnw. Okay, I think if you're most of you are Windows, right? How to run mvnw in Windows. Okay, so you have something called mvnw.cmd on your Windows file. You can basically run this file and it'll work like a Maven command. Okay, my machine is not Windows, but what I'll do is I'll post some links on this group which will tell you how to install Maven or how to use this Maven W command on Windows. Okay, if you have any issues after that, let me know and I'll be happy to help you. Okay, so first understand that this Maven thing can also be written as mvnw, but when you're writing mvnw, make sure that it is there present in the same folder. Okay, if I open this, if I open this thing, right, I would have to run the Maven command in this. You can see this, you have a Maven WCMD. So you can run this Maven WCMD and that will work just fine. I'm using this Maven W, just this file, because this is for Windows, this is for Linux and Mac OS and everything. Okay, so you would have to, if you're on Windows, you don't have to worry about this. You can just come here and run this thing from the command tools. Okay, if you're on Linux or some other machine, you would do what I'm doing right now. So I would say mvnw, and then I'm issuing two commands, clean and install. What clean does, it cleans all your dependencies. Okay, if I just run clean here, you can see that there's no target folder here. Previously there was target here, but now there is source but no target. Okay, which means it cleared everything, it cleaned everything for you, it removed all the dependencies. Then you can say mvnw install. Okay, it will then basically read your pom.xml. It will basically go ahead, read your pom.xml, and then it will generate the target file for you, which will have everything that you need. Okay, you can see it has a target file. If you go inside this target folder, you can see everything is generated along with the jar. Okay, this part is clear, Ankit Pal?
Yes, sir.
Okay, so instead of generating two commands, we can just say mvnw clean and install, space separated commands. It will do cleaning first and then it will do installation. Okay, cool. We'll take a 5 minutes break and we'll then quickly jump into our Spring application. Okay, अरे यार start Okay, I hope everyone is back. So what we saw so far was basically downloading a Spring application, opening it up on our IDE. We learned about POM, where we saw the parent project, our own project details, properties, and the dependencies. Okay. Then we actually went through the Maven commands. If you have Maven, then do that. If you do not have Maven, you can use the Maven Wrapper command. Okay. This is the dependency cleaning part and all those things. Okay. Let's understand what has been given to us. Okay. You can see here that there is this hello world application, which has only one main method, main string.args, and it basically has this particular line of code. Okay. And it has one annotation. So it's a no-brainer that this is the entry point for a Spring application. When your Spring application starts, because Spring at the end of the day is a Java application, and this Java application needs a public static void main with string as the arguments. Okay, string array as the argument. So this is the plain. This part is a plain Java application. How you would run any Java application. Okay, then look what's happening here. You have a Spring application class which has a method called run. This, by the way, is a static method. If I click on this, uh, let me download the sources. Acha, you can see here that forget about all of these things. Okay, what these are. Forget about what these things are. Don't worry about this. Just know that this is a static method. Okay, which means this is more like a utility class. Okay, so Spring application has this run method, and inside of which we're passing our own class along with whichever arguments are passed here. Okay, this is different because this application is going to first read this class. Okay, what it I'll tell you what it does. Okay, when you pass your class inside of Spring application.run along with the arguments that are given here. Okay, there are two things that happens. All such annotations, they become alive, like they start to do what they're supposed to do, and this entire application becomes a Spring application because internally it starts to basically create behind the scene. It starts creating a Spring container, and then if you have a Spring bean written somewhere, it starts registering and doing all of those things. This is the starting point of your Spring application. When you basically when this run method starts scanning this hello world application.class, if you click on this, it actually brings you to this. So when it encounters the Spring Boot application annotation, it immediately knows that this is not going to be a typical Java application, and it needs to be something different from a typical Java application. This annotation basically specifies that this application is going to be a web application. Okay, this annotation has basically a bunch of processors, typical Java classes, which will scan and look for this particular annotation. The moment it finds this annotation, it will treat the class differently. Okay, any questions here? I will repeat it again. This is the starting point for a Spring application. The only component you would ever write in this class is Spring application.run, and where you would pass your main classes dot class. Okay, this is your main class, so dot class, and the arguments that came with this. Okay, and then you would also annotate. This is the starting point of your application, your starting class. So on that starting class, you would have something called Spring Boot application. This allows the Spring framework to come into action. When you pass this class inside of this, and then you have this annotation, what it does is it first checks, okay, who is the parent folder of this guy. The parent folder is in.geekster.springtutorial.hello world, which means any class or packages or sub packages under this package will be considered as a Spring application or part of this Spring application. Okay, does this make sense? Any confusion so far? Let me look at the chats here. Is there anyone? Okay, no questions. Okay, so this is what you absolutely need to have at your entry point, Spring Boot application, and then it will start behaving like a Spring Boot application. This is a bare minimum code, so we'll just go ahead and do these things. MVN clean install. Okay, and if you are familiar with command line programming, you can pair up one command with another using and. Okay, so I won't do that because if it's difficult for you to understand, what I'll do is I'll just run this command first. Let me explain this to you for a bit. Okay, so this, you are basically, when you run this command, you're looking for this build success. If anything doesn't work here, if the build fails, you know that there's something wrong in your project. Okay, I'll deliberately fail the build by making some silly mistake. Okay, you will see this build failure. If there's any kind of issue there, they will always give you this build failure. Okay, now change it back. Let's run this again. Okay, before this build success happens, you can see that there are these test run one, failure zero. Okay, all of these things. What exactly is this? When you run mvn clean install, Maven goes here inside this test folder and runs whatever test cases are there. For now, there is no test case. It's just a blank thing. So it just says here tests, and it basically reads or creates all of these test files automatically and then tests your test case, and then it runs the application here for some time. You can see that this Spring logo here, this is the famous Spring logo with the version and everything. It's written Spring Boot. So your application actually runs behind the scene for some time, and then once the test is over, it stops the, like, it shuts down the application, and then it gives you the build, which is the .jar file. Okay, that's all it does. If you want to skip this thing, you can always issue this command d skip tests. Okay, this is important. Let me actually, what we're doing here is we're saying first clean whatever dependencies are there, then install, like rebuild everything. At the time of rebuilding, this -d is how Maven understands commands. Okay, and then skip tests, this is basically the command keyword which will skip the test. Okay, if I run this command right now, you will not see this test anywhere. Cool, there's no test, nothing, no test whatsoever. This is how we can skip the tests. Okay, when you're working in production or for a company, you would never do the skip tests, but when you're developing something on your own computer, you can always use this skip test. Okay, especially if you're not writing any test cases, then you can always use this skip test, and that should be fine. Okay, so from now on we'll follow the same command. And by the way, if you're using Maven Wrapper, you would have to basically use this. That's all. That's the only change you have to do. Okay, cool. This generates a jar file in our target folder. If we look at our target folder, you can see our target folder has this snapshot .jar. Okay, where is this coming from? Let me tell you how this naming convention is done. You come to POM. What is the name of your application? Hello world. So hello world. Then hyphen. What is the version of your application? The version is 001 snapshot. So it's basically name hyphen version .jar. Okay, this is how you generate your application's name. This is auto generated, by the way. Okay, cool. Now what I'll do is I'll try to run this Java file. I'm sorry, jar file. Okay, so I'll say Java hyphen jar. Okay, then it's inside the target folder. So target hello world and the .jar. If you see this thing, it will spring up, and then it is here. It says started hello application, and there are a couple of interesting things you should look at this log. Okay, first of all, when you see this logo, you know that it's a Spring application. This here says the version of the application. We're using 2.6.5, and then this here says that this is a Spring Boot application. Okay, in here you can see this is the thread that is running your application. It is a main thread which is running. So all of these will have a main thread. It's a single thread that's running all of these things. This is the packaging name shortened. Okay, what is it? I stands for in, G stands for Geekster, S stands for Spring Tutorial, H stands for Hello World app, and then the actual Java name, Java class name, Hello World app application. Here, these logs are actually auto generated. Okay, they are coming, they're automatically generated here. You can ignore these things. Look at this thing. It says Tomcat initialized with port 8080. What is Tomcat here? You can see here it comes from Tomcat web server. So remember how I was telling you that you need a jar. So if you chose just a war file, it would have just given you the Java classes. You would not have a web server. Then you would have to do your web server. You would have to install your web server and run it there. That's a huge pain. Okay, which is why we always select jar. The jar comes with a web server, which is usually the Tomcat web server. This Tomcat web server, you can imagine it like a bucket. In this bucket you have your Spring application running, and this bucket can have, like, there is this 8080 port, which is the I'm pretty sure you're not familiar with the concept of port, but just know that machine an operating system has lots of ports ranging from 0 to I think 65,000 something port. Okay, uh, ports are sort of like mm, doors into a single house. Okay, we're just using door number 8080 to enter into the OS. That's it. Just know this thing. Okay, I'll repeat that again. Port numbers are basically doors. You can imagine your computer with lots of doors, 65,000 doors. In of those doors, you're just using 8080. Okay, to enter into the OS, because at the end of the day, you have to talk to the OS to basically do all your stuff. Okay. Any questions so far? Anything you want me to explain again,
No, sir.
Abhishek? Cool. Okay. So I'm actually assuming that you are understanding everything. If you have any questions, let me know right now, because that'll be easier. Okay. When you see this line here, Tomcat started on port 8080, you know that your application is running. And you can see this last line. Always the last line would be started hello world application, and then in 2.3 seconds. Okay. This is the typical log for your Spring application. Your Spring application is up and running. Okay. It has nothing. It has no Spring Bean, nothing whatsoever. But behind the scene, it already has created this guy for you. It has already created the Spring container for you, but you don't know that yet. Okay, you will only get to know it when you start implementing a Spring Bean. Okay, so let's just jump into the so far we have what we have done is we have walked through a Spring application, and we know that Spring container has been created behind the scene. Let's actually go ahead and create a Spring Bean. I told you that a Spring Bean is basically a simple Java bean with like a simple Java class with methods and variables, but it has a life cycle attached to it. Okay, so what I would do is I would come here and I would create a sample bean. Okay, sample Java bean. Okay, okay, that's it. What I'll do is I'll say private static final. Let's say actually let's not keep it this thing. Let's just say that final string name. Okay. What I'll do now is I'll say public sample Java bean. I'm basically creating a constructor, and I'll initialize this name at the constructor level. So I'll just say name equals sample app. Okay, that's it. I'll expose a method just to read it. Okay, read name. There's nothing fancy, nothing funny going here. It's just a simple Java class. Okay, there's nothing. It's not a Spring Bean yet. In order for you to convert this into a Spring Bean, add this annotation called component. Okay, this does two things. Okay, hear me out. This basically does two things. It first says that this is a Java class, but it is also a Spring Bean. Okay, which means it will have a life cycle and all of those things. It will go through this phase that I showed you. Okay, it will go through this phase, whereas it will be initiated, instantiated. Then if it has any dependencies, it'll do them. If it doesn't have, it'll directly move on to this. If it doesn't find anything to do here, it'll move on to this part, and it'll stay here as long as your application is running. When your application shuts down, it will then move on to this, and then it will permanently shut it down. So the moment you specify this as add component, all of these things start happening behind the scene. Okay, this class has no dependency. There is nothing that is being injected from outside. Okay, there's nothing that this class depends on. So it has no dependency. So it will basically skip this phase, and it will directly give me my custom utility method, which is my method here. Okay, any questions so far? Any questions on this? Anything you want me to repeat again? Cool. Okay, let's see how we can actually use this thing. So okay, so the first part was that the component does two things. First is registration. Let's try to understand this thing. Okay, this at component annotation, it does two things. It first turns simple Java class. Actually, you know what? Let me write it here so that it will be easier for you to understand when you're going through the code. The following component. Okay. Okay, if you're confused about the lifecycle attachment part, don't worry, we'll understand it with example. The second thing is okay. It does two things. It first attaches a lifecycle to it and turns this simple class into a Spring Bean. Okay, and then it basically registers itself. I told you that a Spring container or any container has two parts, registration and retrieval. Okay, registration part is being done by this. When you say add component, it basically calls the Spring container, because when we didn't have this class, even then the Spring container was already created behind the scene, but the Spring container was sitting empty. It didn't have any classes to look at other than this class. Okay, this class was the only Spring Bean that Spring container had. But then when you annotate this class with add component, what it does is it then goes ahead and registers this class as one of the Spring Beans. Okay, now you can, or you may or may not give a name to this particular bean. Okay, if you decide to not provide a name for this, the registration name would be something like this. Your class name is sample Java bean. Okay, so it will be mapped like this: sample Java bean, and then it will point to the memory of your whatever this object is created. Okay, it will point to that object. This is if you do not provide a name to it. Okay, if you do provide a name to it, this is how you do it: sample XYZ. Okay, remember the container class that we were discussing? We had to give a name and the class itself to register. This is what it's doing. It is basically taking it, this part is doing two things, part of which is registering itself, and then it's giving the keyword or the name by which you will recognize this thing. Usually we never give names like this because we want to use the simple, like we'll take whatever default name is there. So that's it. This is it. This is done. Now this is the registration part of the bean. Okay, how do we read that bean, or how do we retrieve that bean? Okay, to retrieve that bean, we have to basically create an instance, like we have to create a field of that class. So we want a sample Java bean. So we'll say sample Java bean, and we'll just call it bean. Okay. Now this is just the moment I write this thing, right? Spring, you can see, you can tell that this is a dependency of this class. If I'm building this class itself, this class will be having a dependency on simple sample Java bean. Okay. But as of now, it won't do anything. Let me see how. Okay. I'll write a simple method here. Um, Public void run. Okay. There's just a simple method here where I'll just say sam bean dot read name. Okay. And I'll basically print it out. Okay. Now, in order for this to run, I'll add an annotation called post construct. Don't worry about this post construct. We'll come to the post construct later. But just know that when after this application has run and is ready to be used, it will call this particular method. Okay. Let's see what happens when we do this. Okay, so let's take a look at the class again. This is again a Spring Bean. Okay, and basically what happens is I'm starting this application, then I'm saying that I have a dependency on this particular guy. Okay, this particular sample Java bean here, and run a particular method on this when you're done. When you're done creating this hello world application. Okay, that's all that's going on here. I'll close this thing. I will basically do a mvn clean install d skip tests. Okay, and immediately after this I want to execute one more command. So you would give and java -jar inside the target folder hello world application. Okay, this is me doing two commands together at the same time. I was doing this thing, and then with and I did this. So it will first run this command, and after this execution is complete, it will pick up this execution. Like this in command line tool, you can do this and you can add how many number of commands you want to execute. Okay, so I'll do this and we'll see what happens. You can see that it failed, and it failed with the famous NPE, also known as null pointer exception. Okay, it says caused by null. This is what is called an error stack trace. When I was telling you about exceptions, I mentioned the word called stack trace. Basically, this is what a stack trace looks like. It gives you all the details of where the first error happened and where it came from. So let's take a look at this thing. It comes from bean. It throws an exception called bean creation exception. Okay, which is a custom exception of Spring parent project. Okay. Then you have this thing. It says error creating bean with the name hello world application. So basically it's saying that it could not even create this bean. Our main application could not even be created. Okay. What is the reason for this? It says invocation of init method failed. Nested exception is Java this thing. Okay, pay attention to the word init method. Okay, and then take a look at this word custom init method. Okay, I did not have any method called init. I just wrote something which was taken as an init method. This is what this post construct does. What happened here was container started, the bean was instantiated, as in the memory was allocated. Then it tried to it realized that it has no dependency. Okay, it basically has no dependencies, because even though you have mentioned it here, there is nothing here signaling that it's a dependency. I mean, you could have just written something like this. You could have just written something like bean dot new sample Java bean, right? So at the time of compilation, the application doesn't know whether this is a dependency that has to be injected from outside, or it's something that you'll be creating inside. So it just assumes that it's there. Okay, so it skips this part because there is no dependency. It then comes to the custom init method. This custom init method is basically the place where you initialize your code before you can start using your method. Okay, this init method, even though I have not written an init method, whatever method I write, I have given something called post construct. Okay, post construct, whenever you annotate a method called post construct, it will basically take that as this phase. Okay, so whatever code you have at that point, it will run. And post construct you can apply on basically one method only. You can have only one method with the annotation of post construct. So what it's trying to do is it's saying that, hey, run this, call this read name method on this thing. But this bean object has not been initialized, right? Which means that at this point, by default, this guy is a null object or is just a null. Hence the pointer, null pointer exception error. Okay. Do you have any confusion here? I'll repeat again. If you have any confusion, let me know. Okay. All right. So basically, it is a typical learn pointer extension because even though I am using this guy, I have not initialized it anywhere. Okay. So I can either do this bean equals to new sample Java bean, but then this is an example of tight coupling. Hello. Yeah. Who's this? Anish Kumar. You have a question? Okay, cool. This, I can either do this, but then as we saw from yesterday, this tightly couples my method with the creation. I don't need to create the Java bean, right? I just need to work with it because I'm just calling this particular guy. So what I'm going to do is I'll say, hey, give me what I need from outside. Okay. So in order for you to do that, like how you registered this bean with at component annotation, you would retrieve it with the auto wired annotation. Okay. When you specify this auto wired annotation, what it does is it then says it, I'll tell you what happens here. Container starts, it recognizes that my first class in the line is this hello world application. So it starts building this thing. At the time of building, it realizes that there is a dependency injected into it. Okay. Because you have given this auto wired. So it basically marks, it signals that there is something somewhere which you are trying to inject into yourself. Okay. You can see that we're not doing something like this. I mean, we're not saying something like this. Okay. We're just saying that we will have methods without such arguments, but just inject this to me when you create this class. Okay. What it does, it goes to the Spring container, and Spring container is like a map. Okay. It's like this. It's like this. It's like a map. Let's say you have sample bean 1, 2, 3. Okay. So it basically says, give me the object that has been created, which is of type sample Java bean. Okay. So it then goes and checks in its memory. Hey, do I have anything in my container? So it is not there at this point because this is the hello world is the first class that was getting created. At this point, it encountered that there is this class that needs to be created. So in this dependencies injected phase, it first creates the dependency, which means internally it will first create the dependency and then it will supply that reference to you. Okay. You will then have this sample Java bean injected into you. And then basically it moves into your custom init method part. The custom init method part is recognized by the at post construct. Okay. At post construct, it will run this sample thing. And this time you can see it will actually work. Like if I go ahead and run this command again, Acha. Where is my Spring application starting? No active profile customer starting with engine. Look at this. You see this sample app, this name coming here. Where is this coming from? It's coming from this read name method, which is basically the sample app here. Okay. So you can see that it basically, before it said that started hello world application. This phase means that your application is ready to use. It's ready to be used. Okay. You can see this log came before that. Before it was given to you for using, this log came before that, which means it happened at this phase. When you see this last line, okay, you are in this. Okay. So this is basically how the life cycle works. We'll also see with one more example what destroy method does. Okay. Let me know if you have any confusion or if you want me to explain whatever just happened. I'll explain again.
Sir, please explain code again, sir.
Code, okay. Okay, so first thing, we created this Spring Hello World application. Forget about these two things, okay? We created this Spring Hello World application, okay? And it was just a normal Spring Bean. What it did was it created an empty Spring container, okay? It was an empty Spring container. It just instantiated this bean. It created this bean. No dependency, so it skipped this. There was no init method, so it skipped this. And it was ready to be used, okay? If you run this method, you cannot see that sample app anywhere used. It just says started hello world application. This line basically means your bean, this hello world application, Spring Boot application bean, it's actually in this phase. You can now start using this thing, okay? That's what happened. Now, basically what I said is I want to create my own custom bean. So I created this simple Java class called sample Java bean. I wrote my method here and I have this simple variable, which I'm returning by using a read name method, okay? Now, I have to register this. I have to register this particular bean with Spring container. So for that, I had this at component annotation. It did two things. First, it turned this sample Java, simple Java class into a Spring Java class. Okay. And then it basically registered itself with this container. Okay. This part is understood. This creates a Spring Bean and it registers it with the component. Now in here, I have not given any name, so it will basically take this class name as the component name. Okay, it will basically create this here. Okay, sample Java bean this. If I did give a name here, let's say XYZ, then it would have been changed to XYZ. Okay, this much is clear. Now I'll just remove this. Okay, so this was the registration part. In my container, I told you that it was the registration part. Okay, after this registration is done, okay, now this is a Spring Bean. This is also a Spring Bean. Both of these are Spring Beans. Now, basically what I did here was I said that I have, sorry, I said that in order for this bean to function, I have a dependency on this bean, a bean of this sample Java type. And how do I retrieve that bean? By using this at autowired annotation. So what will happen behind the scene is it will create the hello world, it will instantiate this, and then it will go to the dependencies part. As it is going through this, it will check that there is a bean here, which is a dependency into this class. Okay, so it will go behind the scene and it will check that have I created this object? If I have not created this object, I will create this object and then I will pass that object into this. Okay, if it is already created, I will just simply reuse the object to this. Okay, this much part is clear what this is doing, Abhishek?
No, sir.
This is not clear. Okay, you understood this part? Did you understand this add component part?
Yes, sir. Component part is clear, sir. But auto
This was the registration part. Auto wired part. Okay, so you remember that we were working with methods like this yesterday. I was saying something like this. Let's say I have some sample method. Okay. Do you remember this method that we were working with yesterday, where I said that this will be injected into my method? Okay. This is your dependency injection because somebody is creating the list from outside and is injecting into your object. Okay. Sorry, into your method. This is the method level injection. What I'm doing here is I am saying a class level injection. Now class doesn't have any parameter here, right? There's nothing like this. A method has a parameter, but class doesn't have it. So how do you inject something inside a class? You can inject it using this. You create that as a field and then you annotate this as auto wired. This auto wired basically does this retrieval part. Okay. Is this clear what I'm doing here? What I did here, what I did here, I mentioned that, hey, inject this thing into me. I'm basically removing this and I'm saying, does it make sense now, Abhishek?
Yes, sir.
Okay, cool. So that's how I basically inject this thing. So when I specify this auto-wired keyword here, right, it will basically inject your dependency. It will inject your dependency inside your class, which means at this phase, this guy, this sample Java bean will be ready for use. Okay. Now, I also had this particular method here, which was a run method. I mean, this is my custom method here, and it is just using a method of this dependency bean. Our bean is a dependency bean. I'm just calling a method on that dependency bean. Okay. Now, if I do not give this thing, and if I just run without this, okay, if I just run without this, you won't see that sample app line anywhere, because in this bean, it is, this run is just a simple method. Nobody's calling this run method. It's just a simple method here. It's just sitting there. If it gets called by someone, it will execute. Otherwise, it won't be executed. But the moment I add post construct annotation to it, this particular method will be run in this phase. Okay. The custom init phase that I talked about. The moment you specify post construct, when the bean is being created, at this phase, it will look for all the methods, or it will look for one method with the post construct, and it will basically execute this method. So this is init here. Maybe if I just change this method name to init, this will, it will basically do the same thing. So it will come to this custom init method here and it will execute. Is this part clear, Abhishek?
Yes, sir.
Acha, ठीक है? Cool, cool. So that's what's basically happening here. So what did we do here? This is our Spring application. Okay. In our Spring application, it was first registered into the Spring Bean with this annotation, SpringBoot application, and this will be only once. Whichever class is your starting point, there you will have to write this as Spring Boot application. You cannot write at component here. It will not work. At component is only for non-starting point classes. Okay. This is a non-starting point class. This is not a starting point. It's just a simple Java bean, a simple Spring Bean registering itself, and then that's it. Okay. So this is how it happens. Now, I told you that this guy, because this is a add component, this is a Spring Bean, this guy also has a life cycle. So how do we see this thing? Let me create a public void init method, and let's run this command, system out. Hi, new line. Hey there. Okay. This part will be executed. Void. Or let's just call it destroy. Okay. Okay. Right now, this is just a simple, these are just simple methods. Okay. What I want is, I want this method to execute when the Spring is being initialized, but not ready to use yet. Okay. Again, I want this method, init method, to run at this phase. What is this phase? This phase is between the dependencies injected and just ready to be used. At this phase, the object is not yet ready to be used. Okay. It is still being built. After this phase, when you come here, custom utility method, this is the phase where your class is being built. So when I annotate this thing with post construct, I basically say that in this Spring's lifecycle, when you come to this phase, execute this method. Okay, let's see what happens now. Huh. You can see this, right? This is your root web application. Okay, and you can see that there is this hey there coming up here, and then there's a sample app. Interestingly, check this out. Your, I told you, right, Spring first starts with the parent class. Okay, like the first object that has to be created. Who is the first object? First object is this hello world application. Okay, this hello world application says that I have a dependency on Spring Bean. So it then goes ahead and it checks, do I have this sample Java bean created in my memory? If I do not have this thing created in my memory, I will go ahead and create it. So what happens is, it then at this point, it then creates that object. Okay, so if you look at the logs here, after this point, it basically created the sample Java bean object itself, which is why this hey there part got executed. Where is this hey there coming from? Hey there is coming from this sample Java bean. So this part got executed. Once this was built, then it actually came here, it built this thing, and then it executed this method, which is why you see this sample app. Okay, any confusion is in here? It first created this dependency object. It created the dependency object. At the time of creating this dependency object, it basically executed the init method inside of this thing. Okay, which is why we see this hey there init method. Now once for this bean, this phase was ready to use, it then went back to your hello world application. So after this init method was done, it went back to your hello world application, and it then executed the hello world's init. Okay, so it created the dependencies and injected the dependencies, and then for the hello world application, it came to init method. Is this part clear or confusing? Maybe if I just give a pictorial, it will be easy. Okay, let's see how things are happening. Let's say, let's use a pencil here. It will be easy. Okay, let's say I am using this container wala class, okay, which is this hello world wala class. And at this point, I realized I have a dependency on this thing, sample Java bean. So I jump out of it. I create the sample Java bean. I create the sample Java bean. Okay. Then I basically inject that sample Java bean in here. Then I complete my class. Okay. If I write this thing, this is your hello world. Okay. And is this clear to everyone? At the time of creating, it figured out that I have a dependency. That dependency is not created. It went ahead and created this thing, and then it injected. Now let's say theoretically there was another bean there somewhere. Okay, so what I was doing was let's say I'm creating one more bean. Can I change the color here? Let's say there is another Spring Bean here, which figure out that I have another dependency. So what it will do is, it will, instead of creating it, it will basically inject it here, and then it will complete its class. Okay. Did you understand what happened here? Hello world was the starting point. So at the time of creating this bean, it figured out that I have a Java object which is not created. So it created it first. This green one says that it created it first, and then it injected it. Now, when this guy was being built simultaneously, let's say I have a hello world 2 here, which is not a Spring Boot application, but a component. At that point, you will see that Spring Bean being injected and not recreated. Okay. Example of that would be if I just go ahead and create a hello world app. Okay. Mark this as component. And I don't do anything here. I just say sample Java Bean, and I say auto wired. Okay. Let's see what happens. Okay. How do we know that this is actually also working? So let me go ahead and write a post run init on this. Running hello world 2. Okay. Check out the logs here. Okay. It first created the dependency bean. Okay. And then it ran this sample app. This sample app is being called by your main applications entry point Spring Bean. Okay. Now, once this was there, it also figured out that there is one more hello world app, which is basically a Spring Bean, which has a dependency on this thing. You don't see that hey there object being created again. It was only created once. So what it's doing is it first created the object, then it injected. The second time it was called, it didn't have to create this again. It just reused the object. Is this part clear to anyone? Or is it confusing to anyone? Let me know. I'll explain again.
Confusing, sir.
Confusing?
Yeah, sir.
Okay. And let's take a look at this picture. What did I do here? I was creating the hello world application, and the hello world realized that I have a dependency on sample Java Bean. Are you clear with this? That when you specify any this thing as auto wired, this becomes a dependency, right? So at the time of creating this thing, it realized that, okay, I don't have sample Java Bean created. So it created the sample Java Bean first. When it created the sample Java Bean, I have a method in my sample Java Bean in this init method, which got executed. Okay. When this particular bean was getting created, it was also going through the same life cycle. Okay. So it jumped onto the sample Java Beans lifecycle. It went through all of these things and it executed this init method on sample Java Bean. So that's why you see this log here. This hey there is coming from sample Java Bean. Once that was done, it then basically went back to your hello world application. Because if you look at this diagram here, I jumped out of it to create it. Once the creation was done, I came back to my application. So now it executed the init method of my original application, which is sample app. Okay, you can see this thing. In this, I basically call this read name and I print it here. This init method is whose hello world application. So this runs. Now, once this is done, Spring realizes that I have one more bean, which has a dependency on sample Java Bean. So what it does at that point, it checks, do I have a sample Java Bean created anywhere? This time there already was a sample Java Bean created by this guy. So it directly injects it into it, which is why you don't see another hey there application, hey there print. You only see running hello world 2, which is coming from this guy. Is this clear, Abhishek?
Yes, sir. Clear, sir.
Okay. So this is basically how these are the life cycles. You need to remember this thing, that this bean has bunch of life cycles. If you're creating a bean and then Spring realizes that the dependencies are there, they will first create the dependency. If not created, if the dependencies were already created previously, they will just inject it into your this thing. Then they will run your custom init method. Then it will be ready for you to use. Now, what is this custom destroy method? Custom destroy method will be called when your application is about to shut down. Okay. And for that to happen, you only need to have one more method added. Okay. So here I see you have this destroy method. What I will do is I will basically go ahead and add this at post sorry, not post construct, there is something called pre-destroy. Okay, these two annotations are very important. Post construct gives you this phase, pre-destroy gives you this phase. Okay, before the Java virtual machine garbage collects your object, okay, you know about garbage collection in Java. Before they garbage collect your object, they will call this method of yours. So this guy will be executed. Now, my hello world application does not have a pre-destroy, and my hello world app does not have a pre-destroy. So these two classes will be spared. This guy has a pre-destroy, so this particular line will be executed. Let's see how that happens. Let me run this application again. Okay, you can see this hey there sample app running hello world, and you can see this thing started hello world application. This means that my hello world application is now ready to use. If I press Control C on my keyboard, you can see this goodbye coming, right? Where is this goodbye coming from? This goodbye is coming from this pre-destroy method. So just before the application was killed, it basically went into this phase of the life cycle, destroy, and it ran whatever was there, and it basically executed this, and then it killed the application. Okay, if you do the same thing, if you, let's say, copy this part and let's say you put it in this thing, let's call it goodbye 2. Okay, if you run the application again, okay, you can see that these logs, hey there sample app hello world 2, and then if you kill this application, you can see goodbye 2, and then you can see goodbye. Okay, any questions so far? This is how we can basically get into the life cycle of a Spring Bean. Okay, Spring Bean always has these phases where the bean is instantiated, then the dependencies are injected, then the init method is called, and then it's ready for you to use. After you're done with your work, if you're killing your application, it will call the destroy method on it. And in order for you to hook into those life cycle, hook into this phase and this phase, you can write any method. The only constraint is that this method has to be a void. It cannot return anything. It can be a simple public void, some method name, whatever you give here. Post construct would give you the init method, pre-destroy would give you the destroy method, and then you can write whatever code you have here. As we go into deeper levels, we'll see where we can use these two phases to control a lot of things. Okay, you may not understand the exact use of these two methods at this moment, but when you start developing an actual application in the later part of the tutorial, you'll see that these things come very handy here. Okay, any questions so far? If there are no questions, we can stop the session. Cool. There are no questions, so I'll stop the session, and good night. Thank you for joining.